Okay, good. So hopefully you are convinced that accuracy is just one perspective for evaluation of predictive modeling of classification problems, and it's a good practice to have other perspectives as well. And especially there are cases that accuracy is not telling us the whole story. It might be even misleading. So you hopefully also agree that true positive rate and true negative rate, just because I mentioned them, might be helpful here. So the thing is how to calculate them. Okay, accuracy was very straightforward. What about true positive rate and true negative rate? What are their definitions and how can we calculate them? Well, everything starts with confusion matrix. So confusion matrix, or in some sources, coincidence matrix, is a matrix. Matrix of is a matrix of actual outcomes versus predicted outcomes. Let's come back to that example of sunny and cloudy days. So these are the actuals. This is sunny. This is cloudy, and these are predicted. This is sunny, and this is cloudy. But let's go one step behind this matrix, okay? And let's see that how we can count the times that um, we predicted sunny and actually it was sunny here. How many times actually it was sunny and we predicted cloudy here? So these are frequencies, okay? And it starts from here, that these are actuals, these are predictions. So sunny, cloudy, sunny, cloudy, 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 let's say. And the predictions are for this non-naive model. Let's say that this is a non-naive model. This is sunny, cloudy, cloudy, sunny, cloudy, cloudy, cloudy. Okay, so we can count now these combinations. How many times the actual value was sunny and we predicted, our model predicted it as sunny. So this is one, and that's all. So we write one here. How many times the actual value was sunny and our model predicted as cloudy? This is it. So one here. What about actual cloudy predicted sunny? So this is it. Actual cloudy predicted sunny. And the rest are actual cloudy predicted cloudy. 1, 2, 3, 4. So if you sum them up, the summation of these frequencies, this one, this one, this one, and this one, would be equal to the number of predictions. Okay, but we have separated them. We have separated the actual and predicted values based on the outcomes, and we don't need that one, that table anymore. What we have here is called confusion or coincidence matrix. And now we can calculate true positive rate and true negative rate. In order to do so, one of the values, so this is arbitrary uh, designation of one of the outcomes as positive. Okay, so this is arbitrary. There is one hint here. The outcome that matters the most is usually labeled as positive. What do I mean? So, for instance, if the outcome is whether someone is not sick or someone is sick or is ill, then the ill one is something that matters to us. We are worried about. So that one would be labeled as positive. But in general, this is arbitrary. So let's call this one the cloudy positive. Okay, we call this one positive. We call this one positive. Good. And it's important to remember that it is just as equally valid to call sunny positive and call this one negative. Okay, doesn't matter. It's just a choice. In that case, true positive rate, so let me change the color once again. True positive rate is following this formula. It is the rate or the proportions of actually positive cases, so the number of actually positive cases that are predicted as positive. Okay, so what is the number of actually positive cases? If cloudy is positive, the number of actually positive cases would be this one plus this one. And why? Because, well, the actual is here, so this is actual cloudy. Actual cloudy when the prediction is sunny, actual cloudy when the prediction is cloudy. So it is 1 plus 4 equal to 5 on the denominator. So the number of times that they were correctly labeled as positive, it would be shown here. So positive that is labeled as positive, 4. Okay, and this is equal to 4 out of 5, 0.8. So true positive rate is 80%. True positive rate, the definition is the number of the number of times that, or let's say the proportion of actually positive cases that are model labeled correctly. That are model predicted correctly. And when the actual is positive, then prediction correctly means the prediction is positive. Okay? And it is proportion because we are measuring it over all the actual values. So this is the definition for true positive rate. What about the definition of true negative rate? It would be exactly the same. So let me clean this one at the top, because you now know that it is arbitrary to label one of the outcomes as positive. And let me use this one. So we can define true negative rate as well. This is equal to actually, so the number of actually negative cases over the number of correctly labeled negative cases, okay, or predicted as negative correctly. So let me add also this correctly here. This is not just predicted as positive, but predicted as positive correctly. And what is it? The actually negative cases is this one, so it is 1 plus 1, 2. And how many of them are actually predicted correctly? So negative, actually predicted, actually negative, predicted as negative, this would be here. 0.5. So true negative rate is the rate by which our model is labeling the negative cases correctly. Good. So we can see that these two are different. Okay, let's calculate the accuracy now. Accuracy would be the total number of predictions we need. So 1, 1, 1, 4, 7, and the total number of correct prediction. This is a correct prediction, and this is a correct prediction. 5 out of 7. So this is around 71%. So even though accuracy is around 71%, the true negative rate and true positive rate is showing that the model is performing differently in correctly labeling positive cases or negative cases. Now, what should we do with this information? Well, you might think of that it's important for us that if a day is actually sunny, our model predicts it as sunny correctly, because we want to sell some, let's say, anti-UV cream or substance, and we want to put a stand out in the high street. So we don't want to sell the anti-UV substance in a cloudy day. We want to sell it in a sunny day, because people would care about it when there's a sun in the sky and when they feel the sunshine. In that case, you should care about the rate that cares about the sunny, the negative one. So in that case, you want a model to have a very good true negative rate. But if you care about the cloudy ones more, you have to think about the corresponding rate to have a model that has a better corresponding rate. In these cases, anyway, in either of the cases, the accuracy is not telling us the whole story of the problem. The accuracy is telling us a very high level outcome, understanding. We need to go to the details, and true positive rate and true negative rate is telling us both of them are telling us that detailed story. We will see by the end of these lectures that there are different costs for negative or positive outcomes. For now, let's summarize lots of information that you have gained. So we consider one outcome as positive, and this is to somehow arbitrary. The positive rate is correctly predicted positive over all actual positive cases. We want to know that how good our model is for correctly labeling the actual positive cases. Okay, true negative rate is correctly predicted negatives over all actual negative cases. Let's come back to our COVID example. So if having a COVID is considered as positive, then true positive rate would be the rate by which our model correctly predict the ill individuals. And true negative rate would be, so this, since COVID is positive, the rate not healthy, but let's say COVID-free individuals. Okay, so you might want to have a model that has a very good true positive rate. You want a model to have 100% a true positive rate, so no ill individual, no COVID contracted individual would be remained undetected. In that case, this one is more important to you. And we will talk about this fact very soon.